Hello everyone. The aim of this video is to give you an overview of the content you have available for this week. This week is called Distribution of Species in Aquatic System, and we will be studying various aspects of water chemistry. We will be looking at some of the key reactions that gases, specifically CO2, have when they are dissolving in a water body. We're going to be looking at various water chemistry parameters, specifically pH, conductivity and alkalinity, and what they are and how you can use them to assess the water quality in a water body. And we will be looking at something called distribution diagrams, specifically pH diagrams and pH-PE diagrams, and what they are and how they allow us to predict concentrations of different chemicals, pollutants or just chemicals in water. So you've got a few resources. You've got the exercises for the workshop we're going to have on the 10th of November, which we will take in the collaborative course room. You also have the slides for the videos that I used for you to have a look at. You have the content for the week itself split into several videos and of around 10 to 15 minutes each, to try to make it slightly easier to follow. And I'm also giving you a link to a few resources to support the videos and the slides. One is a link to chapter 3 of Harrison, Principles of Environmental Chemistry, and this is what I use as the basis that underpin the most of the content for the week. Again, the book is available through the Novel database. If you do not know how to access the Novel database and you haven't registered yet, please follow this link to a YouTube video which explains how you can create an account or how you can register with the Novel database. It's free for us as members of Canterbury Christchurch. I've got a couple of papers on one of the aspects of the slides, which is alkalinity. The first one, alkalinity addition, is utilizing carbon dioxide and lime. It has a nice introduction section, and it talks about alkalinity and what species contribute to alkalinity and what alkalinity is. And the second one, understanding carbonate equilibria, that's a much more technical paper, so it can be a little difficult to follow if you are too bogged down. Don't get too bogged down by the explanation of how to create the graph. It is not the aim of this module for you to learn to create these graphs. It's for you to be able to use these diagrams, distribution diagrams, to predict concentration of chemicals. But if you want to know what's the underlying science, maths, chemistry that underpins those diagrams, then it's a nice paper. I've also included a couple of links which are not for reading, but just kind of to give you more context. One is an atlas of pH-PE diagrams, so how the authors call it ECHEM diagrams, that has been written specifically using databases with thermodynamic data for all sorts of compounds. And as I mentioned here, it is not for reading. It's 287 pages, but I thought it would be useful for you to see how the authors interrogated databases with thermodynamic data to pull together all these pH-PE diagrams. And finally, a paper from 2014 on arsenic species, a distribution diagram of arsenic species in water. And again, it's beyond the scope of this module. This is a thermodynamics paper, it's a theory paper. It's not the aim of this module that you are able to generate these diagrams. And the aim of the module is for you to understand what those diagrams are and how to use them. But I thought it would be interesting for you to see where they come from. So basically, this paper is around 30-something, almost 40 pages, exclusively dedicated to demonstrate, to put together one of these pH-PE diagrams, the one for arsenic. So as you will see, they cover in almost 40 pages of text and equations. They cover how to generate one of the figures, figure 5 of the paper, which is the pH-PE diagram for arsenic species. So this is all. I hope it was useful. If you have any questions, please do contact me. email.emilia.bertolo@canterbury.ac.uk. But also, I would really encourage you to post in the discussion board, in the two discussion boards for this module, the general one and the one for assessment. I am subscribed to both boards, so I will get a notification when you post, and then we will all benefit from your questions and my answers, so we can create a body of knowledge associated with this module. So this is all. I hope you enjoy the week, and see you soon.